So in this video, we're going to learn how to simplify complex numbers. The first thing that you got to keep in mind is that we're going to assign I squared to -1, and then an I is square root of -1. Okay, so anytime you see -1 and square root of -1, we're going to assign these two values, I squared and I. All right, so it's going to make more sense when we do an example. Let's say you wanted to take the square root of -36. Well, if you do that on your calculator, you're going to get an error message, right? So what we're going to do is we're going to factor out the -1, the square root of -1, and then we're going to assign that as I, okay? And then the square root of 36 is just 6, of course. And then I times 6 is just 6I, okay? Square root of -20 is going to be the same thing. We're going to factor out the -1. And then now we're going to assign the square root of -1 as I. And then now break down the square root of 20 into the product of, the product of 4 and 5. Okay? And then now perfect square, the perfect square is 4, right? Square root of 4 is a perfect square. So we can go ahead and simplify that as 2. And then when we finally multiply everything together, I times 2 is 2I radical 5. And that would be my simplified answer. Okay? All right. Let's do some other examples. And when we do that, we multiply these two together. That's going to give you, can't multiply this together. Whoops, apologize. We have to factor out the -1, right? So this is what this is going to equal. -1 times square root of 2 is the first one. And then the negative square root of 5, we're going to factor out the -1. Okay? And we're going to write it just like that. So this is basically going to be simplified to the square root of -1 is I. Square root of -1 is I. And then when we multiply those two together, okay, we're going to get I square root of 2 times I square root of 5. Okay? So when you multiply those, I times I is going to give you I squared, and then radical 2 times radical 5 is radical 10. Now don't forget, I squared is going to be equal to -1. So remember we had that in the other video, on the other slide. I squared is -1. Okay? And we're going to use that here and replace that. Okay? So I squared is going to replace with -1 times the square root of 10. And then that would be your final answer. So we just got to keep track. So factor out the square root of -1 every time you see a negative square root of a negative number, okay? And you'll be able to simplify it. Okay? Let's do another example. So here, pretty much the same thing, right? We can go ahead and factor out the -1. Same thing for the denominator. And both of those square root of negative 1s are going to replace with I. And then now you should be able to simplify the radicals very simply, okay? So the square root of 4 is 2, okay? And then 2 times I is just 2I. And then the square root of 16 is 4, so 4 times I is just 4I. And then we can go ahead and cancel some things here. We can reduce the 2 over 4, okay? And that's going to equal I over 2I. And then we can cancel the i's. And then you're just left with 1 over 2. There's an imaginary 1 here, so we can write that. 1/2 would be your answer. Okay? Let's go ahead and do another one like that, just to make sure that you're understanding. So we have the square root of negative 45 over the square root of negative 80 and the square root of negative 45. So we're going to factor out the square root of negative 1. That way you know we're replacing both of those with I. Okay? And you don't have to worry about them. Now, go ahead and simplify the two radicals. Again, I'm going to use radical 9 times radical 5, because radical 9 is a perfect square. And then the same goes for the bottom. I'm probably going to use radical 16 times radical 5. That way I can get to the answer a little bit quickly, much more quickly. And then now go ahead and simplify this. Okay, so we have I, the square root of 9 is 3. Let me write the equal sign, better place here. Square root of 16 is 4. You notice that the radical 5's cancel. And then also the i's cancel. And then now I just have 3 over 4 as my final answer. So when things are equal in the numerator and denominator, you can cancel them right out. All right? Okay. So let's look at the next slide. And some information that, higher powers of I, right? So these would be higher powers of I. Okay. So remember, anything to the 0 power is just 1. If you have I to the first power, that's just I. If you have I to the second power, then that's just going to be a minus 1. If you have I to the third power, then that's just going to give me a minus I. And then if you have I to the fourth, you're going to get 1. Actually, let me go ahead and rewrite it in a new column. Okay. So yeah, I to the 0 is 1, I to the first is I to the second is minus 1, I to the third is negative I, then the pattern repeats. So when you have I to the fourth, it's going to be 1. I to the fifth is going to be I. I to the sixth is going to be a minus 1. I to the seventh power is going to give you minus I. See how that works? The pattern repeats. So what do you think I to the eighth is going to be? again, it's going to be 1. The pattern repeats, right? I to the 9th is going to be I. I to the 10th is going to be a minus 1. I to the 11th is going to be minus I. Okay, so keep that in mind when we do higher powers of I. So on the next slide, when we look at I to the 11th power, we're going to simplify that to I to the 10th times I. And as many combinations you can use, okay? And if you go back to the original slide, I to the 10th was negative 1, right? See right here? Okay? So you can replace it with your chart. Maybe have like a chart, break it down like I did here, okay? You can use any two combinations as long as you get the exponent 11, as long as the product of these two give me exponent 11, and then you're just going to substitute what you have from the chart. So I to the 10th we said was negative 1, right? And then, okay, and then, okay, times I, right? And when you simplify that, that's just going to give me a minus I, because a negative 1 times I is negative I. Okay? Let's do another one. Let's say you had I to the 36 power. Okay? So break these down into simpler numbers, under 10 if you can, right? So I would probably just do I to the 6th power times 6 power. Okay? And if you do it that way, then you can replace I to the 6th power. From your previous table, I to the 6th power is negative 1. So you can replace this as negative 1 to the 6th power. And then now that's like saying negative 1 times itself 6 times. When you do that, you should get a positive 1. Does that make sense? So let me just go ahead and show you that this means negative 1 times negative 1 times negative 1 6 times. And then that's just going to equal 1. Okay? So just showing you how that's broken down. Okay? So let's say you had, whoops, sorry. So let's say you had I to the 72 power. Okay? You can do it like this. To make this a little easier, you can say I to the 10th. Whoops, I'm sorry. I meant to say something else. You could say I to the 70th times I to the 2nd power. Okay? And then you can break that down. You can break I to the 70th power to I to the 10th raised to the 7th power times I squared. I squared stays the same for now. And then I to the 10th from your previous table can be replaced with negative 1. So you can say negative 1 to the 10th power. Oh, I'm sorry. You can place you can play I to the 10th, replace that with negative 1 raised to the 7th power. Okay? And then you can replace I squared with negative 1. Okay? And then now that simplifies to, well, negative 1 to the 7th power, okay, it's still going to give me a minus 1, and then times that by a minus 1, and we should get positive 1. Okay? So it's just a matter of how you want to break down the exponents. Let's try to think of combinations where you can replace -1. Okay? So if you have a larger exponent, break that down to an exponent raised to another exponent so that you can replace one of the base with a -1. Okay? So here I replaced this with a -1 because I broke 70 as 10 times 7. Okay? And then I squared, that's just replaced with a -1 here. Okay? So you try to think of combinations that are easier to work with. Okay? You can do many combinations here, so that's really up to you. This is just one possible way of doing it. Okay? So just kind of keep that in mind. All right? So let's go ahead and go to the next slide. And a couple of things I want to talk about is adding and subtracting complex numbers. Okay? So, just a couple things, piece of information, okay? When we talk about imaginary numbers, so complex numbers, okay, we want to write them in standard form. So this is in standard form. Okay, where the A and B are real parts. Okay, so the A and the B are the real parts. And the I is the imaginary part. Okay? So a complex number is a real number if B is 0. Okay? So keep that in mind, okay? So sorry, my pen keeps sliding. So remember, a complex number, okay, is a real number if B is 0. Okay? So it is purely imaginary, okay, if A equals 0 and B doesn't equal 0. So I want you to think of something really quick here, okay? So remember, the imaginary unit is I, so that's always an I, right? I told you that here, okay? So when you have a complex number, okay, remember, it's going to be A plus BI. And you got to keep in mind that your A and B are real numbers, okay? An imaginary number, again, you're going to have A plus BI, where B cannot equal 0. Okay? Because if b is 0, then you just have a constant, right? That's no longer imaginary. And then, of course, pure imaginary numbers, or pure imaginary number, rather, nothing to be plus. Okay. Can you have 0 plus bi, and that equals just bi, or b obviously cannot equal 0. Okay? And then if you have a real number, okay, a real number, then you have a plus 0i, and that's just going to equal a, right? Because 0 times an imaginary number is just 0, then you have a real number now. So just a little FYI, a little information when we talk about imaginary numbers, okay? All right, let's go to the next slide. Whoops, okay. And let's go ahead and add and subtract a couple of imaginary numbers. So the first example, okay, that we have for this is 3 plus 4i plus minus 1 plus 5i. So we want to add those together, okay? And the first thing I want you to do is distribute the plus sign over, right? And we're just going to basically rewrite it without the parentheses because there's an imaginary plus 1 outside this parenthesis, right? There's an imaginary 1 here, so 1 times all of that is just all of that right back. Positive and a negative, remember, is a negative 1. A positive and a positive is still a positive 5i. See, the signs don't change inside when the sign is plus outside the parentheses. So now we just combine like terms. 3 minus 1 is 2 plus 4i plus 5i, right? And then I'm going to combine the 4i and the 5i, which gives us 9i. Okay? All right. And then that's your answer. All right. Let's do another one. And we're going to distribute the minus sign outside of the parentheses. So we have 7i minus 3i minus i. Okay, and then then we have, so then we have 7i, we actually have to combine. 7i minus I is 6i minus 3. And then to write it in standard form, it's minus 3 plus 6i. And that's the form that we should write that in. Okay? All right? Okay. Let's do another example. Okay, we're going to distribute the two negatives here. So that's just going to be right here. We're going to distribute these two. So that's just going to be 5 plus 9i, and then a negative is a positive 4. Okay, we can rewrite 5 plus 9i without the parentheses because there's a positive 1 outside it. And then we just combine like terms. 5 plus 4 is 9 plus 9i, and that's already in standard form. Okay, let's do another one. Again, I'm going to distribute the negative. Everything just stays the same here, so I can rewrite it without the parentheses. A negative times a positive 12 is a minus 12, and this turns into a positive I. Now I can just collect like terms. 6 minus 12 is minus 6. 2i plus I is 3i. And that would be the answer for that one. All right. Okay, let's go to the next slide. And here we're going to multiply complex numbers. And here we're going to just multiply everything together. So that's going to give me 5 times 2 is 10, and then I times I is I squared. Now remember, we're going to replace I squared with negative 1, remember? Okay, so I squared is negative 1, so we're going to replace that with 10 times negative 1, and then you should get negative 10 for your final answer, and that is your solution. Or you can write it in standard form as negative 10 plus 0i. Okay, so that's in standard form. All right. Okay, let's do a couple more. Sorry if my pen's a little choppy there, but so here we're going to use the distributive property here and here. And then now that's just going to give me 7i times 1 is just 7i, of course. 7i times 5 is 35i squared. So remember, we're going to replace I squared, okay, with a negative 1, just like we had before, right? So when we do this, we have 7i plus 35, and replacing I squared with negative 1. So what this simplifies is to 7i minus 35, because a 35 times a minus 1 is negative 35. Of course, we're going to write it in standard form. So we're going to write minus 35 first, then plus 7i second, and then that would be your standard form that we should probably write it into. Okay? All right. So let's do another example. And here we're going to FOIL. So remember doing 2 times 2, which is 4. And then 2 times negative 9i, which is negative 18i. The inside here is positive 18i. Then, of course, 9i times negative 9i is negative 81i squared. We're going to replace that I squared with negative 1 again. Okay? So, the good news is that these cancel. Then you're just left with 4 minus 81 times a minus 1, because we're replacing the I squared with negative 1. And then now that just becomes 4 plus 81, which is going to give me 85. Or we can write it as 85 plus 0i. And that's your solution for that. Okay? All right, let's go to the next slide. And here we're going to talk about dividing. Complex numbers. And we talked about conjugates in the previous video, so we'll mention them briefly. Okay, so remember, if you have a plus bi, right? And you want to know what the complex conjugate is, well, that's going to be a minus bi. So this part here is called the complex conjugate. All right? Then, of course, if you have the product of two complex conjugates, that's always going to equal a squared plus b squared. The plus bi and the minus bi will cancel out. And when you replace the I squareds with the minus 1, okay, everything will simplify to a squared plus b squared. Okay? So just a couple of examples. We'll do one here. So let's say you had 2 minus I over 4 plus I. And what that equals is sorry, I have to do the conjugate. So you notice I'm doing the conjugate. Oh, sorry, I think I'm getting tired. Yeah, definitely getting tired. We're multiplying this by the conjugate on top and bottom. Okay, so that's just going to be a matter of this, right? 2 minus I times 4 minus I. And that's going to be 4 plus I, 4 minus I. You just got to FOIL everything out. Okay, so let's do the numerator, okay? 2 times 4, we'll kind of do that here. 2 times 4 is 8. 2 times minus I is negative 2I. Negative I times 4 is a negative 4I. 2 times a negative I is a negative 2I. So remember, you just FOIL, and then just FOIL here. Okay, does that make sense? Thank goodness, right, so here we go, that's a little bit better. So we're going to do the same in the denominator. We're going to FOIL it out. So 4 times 4 is 16. 4 times minus I is minus 4I. I plus 4 is plus 4I. And then I times negative I is negative I squared. All right. Okay. And yep, I think I made a boo-boo here. When I'm supposed to do negative I times negative I should have written positive I squared. Okay? And now we're in business. Okay, so what we're going to do is combine like terms. So let's do the numerator. So we have 8 and then negative 2 minus 4i. Again, that's negative 6i. And then we're going to replace the I squared with a minus 1. Remember? We have to do that. So here we have 16. The negative 4i and the positive 4i cancel. Minus. And then we're going to replace the I squared with a negative 1. Don't forget it's a minus. And then you replace the I squared with negative 1. So it's a minus times a minus 1. 8 minus 1 is going to be 7 minus 6i for the numerator. And then 16 plus 1 is 17 in the denominator because a negative and a negative is a positive. So this would be my final answer. You have to be very careful. Sorry for the little mishaps there. But you just follow the process and don't forget to replace your I squareds with negative 1. Okay? That's like really important. All right? Okay, and that's what we did. Okay? All right, I think we should do one more example on the next slide and then we'll wrap up the video. Okay? So we'll do one more. 1 plus 2i over 5 plus 3i, okay? And again, we look at the denominator. And we're going to have to multiply the conjugate. 5 minus 3i. And we're going to do the same with the numerator. Okay? So essentially what you're doing is you're foiling 1 plus 2i times 5 minus 3i all over 5 minus 3i. Sorry, 5 plus, here we go, 5 plus 3i times 5 minus 3i. Okay? And it's just a matter of foiling it out. Okay, so, and it's just a matter of foiling it out, okay? So, all right, here we go. So 1 times 5 is 5. 1 times minus 3i is minus 3i. 2i times 5 is 10i. 2i times minus 3i is minus 6i squared, right? 5 times 5 is 25. That's minus 15i. Positive 15i. That's a negative 9i squared. So I'm just foiling the numerator and then the denominator, right? Foiling two binomials. Okay? So we're going to check to make sure that's correct, right? Everything looks good. I'm going to replace, so I'm going to simplify this. Okay? Simplify this. So 5 minus 3 plus 10 is a 7i minus 6. And I'm going to replace the I squared with a minus 1. The bottom is 25. The 15 i's cancel, minus 9. And then I'm going to replace the I squared with a minus 1. So then what I should have is 5 plus 7i. This is a positive 6 now. That's a positive 9. 6 and 5 is 11, plus 7i over 34. And another way you can write this is, if you want to write it in standard form, be 11 over 34 plus 7i over 34. And that would be your standard form. Or actually another way you could write it is this way. You could write the I off to the side. Like that. All right. So I hope you found this video to be very helpful, and thank you for watching.